Now, what if we want to do the same thing, but we want to know where this cosine of theta is negative between 0 and 180? We would say theta equal the inverse cosine of negative 1/4. We could use the calculator for that. And that says theta equal, and let's see how that works. If I take the inverse cosine of negative 1 divided by 4, this is telling me it's 104.5 degrees. 104.5 degrees. That's what it says. Well, let's see. Does that make sense? I'm allowed to be between quadrant 1 and 2 only, because 0 to 180 is right there. So 104.5 degrees is right there. Oops. Crap. Excuse me. So there, that's allowed. That's fine. There is another way I could do this problem. I could ignore the minus. If I ignore the minus, the inverse cosine, inverse sine, inverse tangent will always be acute in quadrant 1. And say 180 minus. That'll work. But since this worked, no need to worry about it. So, again, tangent, if I say, let's use the calculator, theta equal the arctangent of negative 4/3. If I take the inverse tangent of negative 4 divided by 3, I'll get negative 53.1 degrees. Negative 53.1 degrees. Done. Well, not so fast. We have a small issue. I'm allowed to be in those two. But what I notice, this angle is, it's in negative rotation. Well, I can't be in this quadrant because of the limitation. The domain, you restrict the domain. Or another way of saying this, an angle cannot be negative. So, if I am allowed to be only between quadrant 1 and 2, 0 and 180 degrees, all students, isn't all of them positive here? Sine is positive there? Well, wait a minute. Doesn't that mean tangent is negative? I must be in quadrant 2. If I want to use this angle and be in quadrant 2, I need to find the reference angle. The reference angle is simple. The reference angle, you always ignore the plus or minus. You always make it positive. The reference angle, you would say, let's say this was positive. That makes it always in quadrant 1. The reference angle is always in quadrant 1. Then the reference angle will be the inverse tangent of 4 divided by 3. That would be 53.1 degrees. So, if I know that in quadrant 1, my reference angle is 53.1 degrees, I could use the reference angle in any quadrant. If this is 53.1 degrees, what would this angle be? Isn't that 180 minus? That's how you get that. Wouldn't that be 180 minus my answer? That would be 126.9 degrees. The actual answer to this problem would not be negative 53 degrees. Rather, the answer to this problem would be, let's steal this much. Theta would be, what did we say that was? I lost it. 126.9. 126.9 degrees. So the reference angle is a key, and we're going to use that all throughout this course. If I look at part F, I know that theta equal the arc sine of negative 2/3. I use my calculator to figure that out. If I take the inverse sine of negative 2/3, I'll get negative 41.8 degrees. That's what the calculator gives me. Why does it do that? We'll talk about that in chapter 5, 5.5. For now, let's see how this works. We have a problem. That answer is acceptable, of course, but they restricted the domain. They said only go between 0 and 180. Or if I'm solving a problem and you tell me that the angle is negative, we have a problem. So negative 41 is right there. Let me do the same as what I did on the previous. Let me find the reference angle. The reference angle would say take the sine of theta equals positive 2/3. That gives you the angle in quadrant 1. And theta will equal the inverse sine of 2/3. That would be 41.8 degrees. Now, I can be in these quadrants. Where's sine negative? Sine is negative in quadrant 3 or 4. But since the domain doesn't allow me to be there, for this problem, I would say there is no solution. I could get you an answer if you take the restriction off. There's no way you could tell me that I could only be in quadrant 1 and 2, in which the sine is positive in 2 quadrants, and trying to figure out where the sine equal negative. That's impossible. Kind of like when you took your college algebra, and first we said a square can never be negative, so x squared equal negative 4, no solution. Later on, when we gave the complex solutions, then you started getting an answer for that. Kind of like that. Kind of, sort of. How about this problem? The good news. In this section, we're focusing on quadrant 1 in all of those. Keep in mind, this is nothing more than an angle. The only thing an inverse sine, an inverse tangent, an inverse cosine could ever find would be an angle. Nothing else. There is a restriction on this. I'm omitting that and leaving that out of 6.4 because we just need it for applications. When we do get to chapter 5, I'm going to go over that again and go over those. So if I let this be theta, I'm really looking at the cosine of that angle theta. That's all I need. And I know what that is. That is the adjacent over the hypotenuse. It's a ratio. Once I figure out what that is, I'm done. Now, how am I going to figure that out? I'm going to go on the side and say, well, if we let theta equal inverse sine of 2/5, that means I must have had the sine of theta equaling 2/5. And all inverse trig functions, all of them, if they're positive, you're in quadrant 1, and that's the case for us. If I draw my triangle, sine is the opposite over the hypotenuse. And if I use Pythagorean Theorem, this will be the square root of 25 minus 421. So I want the adjacent over the hypotenuse. The adjacent is square root of 21 over 5. Now I know probably you're still confused. That's why I'm doing one of each. So we know this is theta. We know an arc trig function or an inverse trig function is an angle, nothing more. So I'm really in reality looking at the sine of some angle theta. I know how to find that. That's the adjacent divided by the hypotenuse. On the side, I say, look, I let theta equal the inverse tangent of 3 over 7. The only way you can get an inverse if initially you had a tangent in this case. And I know how that works. I know this is in quadrant 1 because it's positive. What if it's negative? That's chapter 5. Here, we're always in chapter 1, in quadrant 1. This is the opposite over the adjacent. That makes this the square root of 49 plus 9, 58. And what's sine? Isn't sine opposite over hypotenuse? The opposite is 3 and the hypotenuse is 58. And there it is. I could use my calculator, but that's not, I mean, here where it says exact, you're not allowed a calculator, but just to show you, if I take the sine of the inverse tangent of 3 divided by 7, I'll get 0.3939, and if I take 3 divided by square root of 58, I'll get 0.3939. But I want the exact, which means calculators are not allowed. How about part C? Well, I'll do the same. This is theta. I'm really looking for the tangent of this angle, theta. Well, I know what that is. That is the opposite over the hypotenuse. It's a ratio. It is, okay, it is the opposite over the adjacent. I would go on the side and say, well, look, if I let theta equal, not that color, it's too light. If I let theta equal the inverse cosine of 1/3, that means the cosine of theta is 1 over 3. My triangle looks like this. Adjacent over hypotenuse, that's the square root of 9 minus 1, which is 8. 2 radical 2. Tan of theta would be the opposite over the adjacent. And I'm done. And there it is. Two more examples on this. What if they give me a variable? It doesn't matter, whatever that is, x, a. I know by now how to do this. I know this is an angle. And I'm looking for the cosine of that angle. Believe it or not, this is what you need for calculus. And I know how to do this. This is nothing more than a ratio of the adjacent over the hypotenuse. On the side, I would say, well, let's see. I let theta equal the arc sine of x, which means I must have had the sine of theta equal x and any number or values over 1. Well, if I go to my triangle, pretty much I'm done. How does that work? I am always in quadrant 1 if it's positive. Opposite over hypotenuse. And how do you find that side? You would say you would say 1 squared equals x squared, and let's call this a. 1 minus x squared equal a squared. If I square root both sides, a equal plus or minus the square root of 1 minus x squared. In this quadrant, a is positive. And I want the cosine. Cosine is the adjacent over the hypotenuse. And that's my answer. I know it's unpleasant, but it's a must. This is something that you really need to get out of the way. Same deal with this problem. If I'm looking at this, say, okay, you know what? I know they mean by that an angle. They didn't give me a number, which means they want an expression. That's okay. That's the sine of theta, what I'm looking for. And I know what that is. That is the opposite over the hypotenuse. Now, I need to create that triangle. Well, if I let theta equal the inverse tangent of x, the only way to get an inverse trig function if I had that tan of theta equal x over 1, that's opposite over adjacent. So I'll create my triangle. And in my triangle, the opposite is x and the adjacent is 1. That makes this the square root of 1 plus x squared. The hypotenuse is always positive because it represents the radius of the circle. And what do I need out of this? I need the opposite over the adjacent. I'm sorry. That's redundant. I need the opposite over the hypotenuse. The opposite is x, and the hypotenuse is the square root of 1 plus x squared. And a quick problem. A 17-foot ladder leans against a tree. Let's say the tree is right there. And let's say the ladder is right there. This is 17. And this is 8. It is leveled. If the base of the ladder, if the base of the ladder is 8 feet from the base of the tree, what is the angle of elevation of the ladder? So if you look at the ladder, what is that angle of elevation? Given, so I didn't bring the height of the tree in yet. Actually, that's beyond the point. That's not what we need. I want the angle really. What is the angle of elevation of the ladder? Well, I'm given an angle, the adjacent and the hypotenuse. Wouldn't that mean the cosine of theta equals 8 over 17? And theta would be what? Inverse cosine of 8 divided by 17. 61.9 degrees. Now, the second part is fairly simple. They say, how high does the ladder reach on the tree? Again, I don't know the height of the tree, right? The tree is there. The ladder is not leaning at the tip of the tree, somewhere. But if I say, hey, how high does that reach? You could use Pythagorean Theorem to figure that out, right? If you use the 69 degrees, now you're rounding. Your answer will be slightly off. I'll let it slide, but then you have to take this into more decimal places if you're going to use it. At least 3. So, you could say 61.928. So, if you're going to use this, the angle, if you can say, well, look, if I want to use the height, right, I could use two things. I could say 17 squared equals 8 squared plus 8 squared. If that's the given information, I'm in good shape because I'm not rounding. 289 equals 8 squared plus 64. 8 squared equals minus 64 225. That means h equal 15 feet. I could have used trig. Let me see what happened if I use the 6.9. If I say, look, I have an angle. I want to use the opposite, and let's say the hypotenuse. The sine of 61.9 degrees equals the height over 17. So if you cross multiply, the height is, again, I'll let it slide if you use this, but you should be a bit careful. And if I take my calculator and say, all right, what is 17 times the sine of 61.9 degrees? I'll get 14.996. Do you see that? Because you rounded. But if I go back and use this instead, if I go back and use 61.928, I'll get 15.000, which is a lot more efficient. All right? So, an inverse, if they give me an inverse, I'm working backwards. If I get to this, I want to spend just a couple of more minutes on it. Really quick, because that's going to come up on your homework. Just 2 minutes. Again, anytime they ask about these angles, you're thinking of a unit circle. If they say, find the following angles. If they say, what is the sine inverse of 1? You don't have to write this, but you do know that this is an angle. So if you let this be theta, that means 1 must have equaled the sine of theta. And where does y equal 1? Y equal 1 only in one place on this whole circle. That's when the angle is what? 90 degrees. And since the initial problem was the green, my answer is 90 degrees and I'm done. If they say, inverse cosine of -1, that's all they want. I'm adding, all of these are additions. I just want to know the answer to that black part of the problem. Well, guess what? This is saying, tell me, where does the x equal -1 on a unit circle? Well, look at the unit circle. X equal -1 only in one place. What's that angle? The answer is 180 degrees. So if you focus just on the black portion, this, whether you're right or not, it doesn't matter. But I want that answer, or pi radians, depending whether you're doing this in degrees or radians. And that would be it for this section.